Welcome to Solid Edge 101. Throughout this course, I plan to provide you with a fundamental understanding of what Solid Edge is and the top 5 business reasons to choose it. My name is Craig Ruchty, an applications engineer from the Global Technical Business Development team, and I'll be your guide through this learning process. At first glance, most of you would likely define Solid Edge as a 3D CAD tool used to design products, machines, vehicles, mechanisms, and more, and you would be partially correct. However, Solid Edge is much more than just a design tool. Solid Edge is an ever-growing portfolio of affordable, easy-to-use tools that address all aspects of the product development process. Key areas of the Solid Edge solution set include 3D design, simulation, manufacturing, data management, and apps. However, with the ever-changing trends and capabilities of technology, the portfolio will continue to evolve to meet the demands of industry. It's the ideal platform for customers to start their digitalization journey, and we'll expand on each of these key segments as we work our way through this course. The first segment is design, and is the core of what Solid Edge is all about. Solid Edge allows designers to intuitively create all aspects of their digital models, starting with conceptualizing and designing individual parts, using those parts to build assemblies, to outputting manufacturing instructions to physically create the design. These capabilities are supported by best-in-class design processes, allowing users to design faster, design better, and design with more confidence. You may be new to the world of CAD, or computer-aided design, but even so, by now you may have heard the tagline, Solid Edge with synchronous technology. But what does that mean? To get a better understanding, let's take a brief look back in the history of CAD. 3D CAD started to become popular in the mid-1990s. Designers used collections of features such as extrusions, lofts, sweeps, revolutions, cuts, and holes to build digital models. Each new feature had to be built on top of the one created before it, utilizing the outcome of the previous in order to create the next. This process has been coined history-based modeling, or ordered modeling as referred to in Solid Edge. Solid Edge has supported ordered modeling methods for over 20 years with both its strengths and inherent challenges. In history-based modeling, the structure and order of features control how models will react to changes or edits. This is valuable because it creates predictable results from edits on underlying sketches using precise dimension changes. Because of this feature control, automating changes and linking features together is quite easy. However, this method of editing also has inherent challenges. For example, if a change needs to be made to a feature created early in the design, the edit must take place on the model at the state that it was in when that feature was created. Once the edit is made, all features created after that point have to be recomputed based on the new inputs, oftentimes breaking downstream features. This forces designers to carefully plan out how they build the model, otherwise the simplest edit could turn into a lot of time in remodeling. And if a part contains large amounts of features, recomputes become quite taxing on computer performance, taking minutes to hours to recalculate the final result. While Solid Edge provides a choice to its users on how they wish to model, most other big names in the CAD industry only offer the history-based method. As there's no way around these inherent design challenges with history-based modelers, what other options are available? Next up, direct modeling. Direct modelers use the complete opposite approach to design, maintaining no history of how a feature or a model is built, allowing for edits directly on the geometry on screen. Like history-based modeling, this contains its own values and challenges. Direct modeling allows fast and flexible edits because there are no sketches driving features that make up the part. Editing is done by simply selecting what you want to change and changing it. With no rebuild of features after the changes, there are no performance issues on edits with direct modelers. However, since there aren't any features or history on how a part is made, creating precision edits or automations using parametric inputs such as dimensions is impossible. This creates a big issue for designers needing precision for their digital models. Some examples of CAD systems using the direct modeling paradigm are listed here. Seeing the challenges associated with each type of modeling, Siemens worked to find an answer that leverages the strengths of each modeling paradigm while negating the weaknesses. This unique solution is known as synchronous technology. Synchronous technology can only be found in solid edge in the mainstream CAD market. Synchronizing the strengths of both history-based and direct modeling paradigms and adding in its own innovative and powerful capabilities, users finally have a powerful solution offering easy-to-use and intuitive workflows. No other single CAD program can do what Solid Edge can do with synchronous technology. Most customers say that their biggest challenge is getting designs done faster. We'll show how Solid Edge not only aids engineers and designers to design faster, but allows them to design better as well. Solid Edge's unique synchronous technology enables customers to be more productive and efficient than ever before. Built-in design tools intuitively help to get initial designs done right the first time. And if any changes need to be made, Solid Edge's synchronous technology allows users to change the model based on what they see on screen, without time-consuming failures due to feature recomputes. By speeding up the initial design phase and making changes faster, Solid Edge customers maintain a level of increased productivity, enabling them to deliver sooner, lower their business risk, and grow revenue at a higher margin, leading to increased satisfaction of their customers. As mentioned earlier, history-based is the most prevalent and well-known modeling method on the market today. With this, it has become commonplace to spend a lot of time and care constructing and constraining complex sketches in order to preserve the intent of a particular design, not only for Solid Edge ordered users, but designers using any other history-based CAD system as seen earlier. However, Solid Edge synchronous technology allows designers to freely make changes to design intent using the 3D model faces themselves, allowing for intuitive changes to designs. This design intent can be changed using 3D dimensions, face relationships, and constraints. The true power of synchronous, however, is that a majority of the design intent of a 3D model is inherently recognized and maintained through the software without any physical actions from the designer. Things like coplanar faces, concentric cylinders, and symmetry are all automatically detected during an edit and can be automatically maintained with no user interaction thanks to the synchronous design intent panel constantly monitoring these conditions. These are reasons why using synchronous technology makes designing faster and better. Without the recipe of how a history-based model was constructed, a designer will need to spend a lot of time interrogating the history structure in order to understand how it was built. This is critical to understand when making edits, otherwise any change made has the potential to create a lot of cleanup and rework, or even potentially destroying the model and forcing a complete redesign. To show a comparison of the two, let's take a look at the process for editing an ordered or history-based model, and then see the same edit using synchronous technology. First, the ordered model. For this example, a designer needs to edit the angle on the front face of this fuel tank. Once we dig into the part and find the feature that controls the angle, we can go and make the desired edit. However, seeing as the base shape was one of the first features created, there's a lot that goes wrong when the change is made, leaving a gaping hole in the middle of the tank and requiring a lot of effort to fix all of the broken features. However, using the exact same model, a user can transform all of the features into synchronous features and then just visually make the changes needed. Notice that no additional design intent has to be added. Solid Edge simply looks after the design while the edit is taking place, giving us our desired change in just a fraction of the time. Now that we understand the basics of synchronous and ordered modeling in Solid Edge, let's take a look at some of the other important functionality offered. To begin, sheet metal. In addition to part design, Solid Edge also accommodates for industry-leading sheet metal design capabilities, with both synchronous and ordered modeling methods. Using powerful straight break and deformed sheet metal specific features and functions, to flattening a complex sheet metal part for detailing and manufacturing, intuitive sheet metal creation with Solid Edge reduces cost and speeds delivery of our customers' designs. Next up, assemblies. Assemblies are made up of collections of parts put together just as they would be in real life, allowing designers to visualize exactly how their designs will look and work. Assemblies can range from just 2 parts all the way up to thousands or millions of parts put together. The larger an assembly, the more difficult it becomes to work with. Working with very large assemblies can be a challenge for any CAD system, but with the many tools included with Solid Edge, specifically designed to help with performance and management of large amounts of design data, it becomes a more manageable task. So let's take a look. First up, zones. Zones make working with large assemblies even more manageable and add to improved performance. Zones allow designers to define a permanent range box to isolate areas of large designs they are responsible for. It doesn't matter whether the parts included in the zones are part of the same assemblies or subassemblies. As long as they're in the viewing area of the zone box, they'll be shown. Once created, using zones to open large assemblies is a great way to access a specific section without needing to fully load the entire assembly. Even if you're using zones, there still could be a large amount of data needing to be accessed at a single time. Another great productivity enhancer for large assemblies is to use simplified versions of complex parts. Using a simplified part significantly reduces the amount of detail needing to be loaded and shown. This improves display performance while still giving engineers a way to completely visualize the design. Simplifying parts in Solid Edge allows design engineers to fully control how they wish to de-feature parts, allowing for representation as a simple, lightweight shape, or isolating key positioning or working geometry. Of course, engineers can easily switch between simplified or detailed versions of models if and when they need. Not all design concepts have to be originated solely in 3D. Solid Edge provides the flexibility to create a virtual product structure before creating files or deciding their position. Start by building your virtual assembly using common part representations. And once the assembly structure is the way that you want it, simply publish the virtual parts list to create the actual part files with associated sketches or components already placed within. This unique hybrid 2D-3D design approach provides engineers a means to quickly create virtual product structures during a design concept and then publish the virtual parts into 3D designs. Just another way Solid Edge allows you to design more efficiently. So we've talked about improving productivity with accessing, viewing, and building assemblies, but what about edits? Once again, synchronous technology comes into play. Not only is synchronous technology great for building and editing parts, but it can be a great productivity booster in assemblies as well. While there are many ways to leverage synchronous in an assembly, geometry modification is a key one for productivity, especially since you can modify multiple parts at the same time. For example, we need to thicken a machine tilt arm, but if it adjusts, multiple parts around it need to adjust as well. No more calculations or writing down values to remember changes. Just select what you want to move and move it. Next up, drawings. Creating 2D drawings from 3D designs is a critical piece of the design to manufacturing process. Solid Edge has the best tool set in the industry for generating drawing views, dimensions, and annotations quickly and efficiently once the 3D model is created. View layout and placement is intuitive and easy, and dimensions and annotations that were used in the 3D design can be automatically retrieved and used on the drawing representations. Once your drawing layout is exactly how you want it, creating a quick sheet allows you to easily duplicate that look and feel, even remembering how you want your detailing to look. Of course, ensuring that your drawings are up to date is critical. Since the drawings are generated from the 3D design, any changes made will be shown through Dimension Tracker, a powerful Solid Edge tool that tracks any changes made to the model and then shows the designer the updates in the drawings. Creating complete drawings quickly is just another way in which Solid Edge decreases time to market, lowers business risk, and helps to grow revenue at a higher margin. As technology continues to progress at a rapid pace, it's important for digital designs to keep up. A key part of this in machine design is the integration of mechanical and electrical components, such as motors and sensors. Whether creating wires, cables, or bundles from scratch, importing complex electrical CAD schematics to create custom harnesses, or simply rerouting or adding wires to existing harnesses, Solid Edge provides easy-to-use tools to virtually route and connect any electrical components with ease. But what about building the harnesses? Solid Edge provides full support for nailboard design, laying out exactly how they'll be put together, from exact cut links to connector and pin locations. And speaking of electronics, printed circuit boards can also be designed in Solid Edge using one of the many integrated apps. Next, let's talk about frames. A large portion of designs utilize frames for either primary components or support structures. Solid Edge provides users with tools to automate frame creation, allowing them to build and control structures using a large delivered library of standard cross sections. Solid Edge also provides a choice in how frames are created. Using synchronous sketches and 3D body edges to place frames provides users flexibility, allowing for simple and intuitive edits. And with universal and individual end condition settings, Solid Edge easily manages corner and connect conditions with full control of miters and coping in a simple one-click process. And as a framework is built, welds are needed to hold them together. Solid Edge offers a complete toolset for weld bead creation. This includes every type of common weld, as well as custom welds and annotations for use in manufacturing drawings. Once built, Solid Edge Simulation can test the frame structures for strength. Solid Edge Simulation not only offers analyses specifically for beams, but also supports static studies for linear, thermal, buckling, and vibration studies on both solid bodies and surfaces. But don't worry, we'll cover more Solid Edge Simulation in just a minute. As is true with most assembly designs, there needs to be fasteners to bolt, screw, or pin components together. Solid Edge provides an extensive library of fastener components based on any common standard and automates their creation and placement. This automation saves designers lots of time and headache not having to model and place the fastener stacks individually. These stacks of bolts, washers, and nuts are automatically determined based on a selection of entrance and exit holes in an assembly. A collection of fitting, standard fasteners will then be presented to the engineer to choose which set will work best. Once a fastener is selected, Solid Edge will automatically generate the parts and assemble them in place. But what about standardized, off-the-shelf parts that aren't fasteners? No worries. Solid Edge also has access to multiple part communities where customers and suppliers share their off-the-shelf components. Once a design or concept has been created, making sure that it is properly represented is important. Solid Edge provides users with best-in-class photorealistic rendering capabilities through world-renowned KeyShot. KeyShot directly reads in models through a live link with Solid Edge, enabling customers to generate photo-quality renderings of their designs for internal or external marketing before the first part is ever produced. Generating photos and animations in KeyShot is a single-click process, maintaining and mapping important information such as colors, orientations, and even pre-existing model animations, saving both time and effort while creating renderings. What we've seen to this point is a subset of some of the most widely used functionality in Solid Edge. These design tools are split out and provided in different product packages depending on a customer's needs. The most common package is Classic and includes most of the basic design capabilities needed in industry. If customers need anything in a more specialized area of design, such as electrical routing, pipes and tubes, or Solid Edge simulation, an upgrade to Premium is the best option. Additionally, Solid Edge provides customers with a choice of how they wish to access their design data, providing licensing options for rental, also known as subscription, perpetual, which is Solid Edge ownership, and cloud licensing available. So there we have it, a nice collection of capabilities that prove invaluable to our customers. But remember at the beginning of the course, we said that Solid Edge was a comprehensive portfolio of tools for customized solutions. And seeing as we've only covered design, let's have a look at what makes up some other key areas of the Solid Edge portfolio. As we touched on earlier, simulation for virtual product testing is part of this portfolio. Solid Edge simulation is intended to be intuitive and easy to set up, created with the design engineer in mind, so you don't have to be a specialist to use it. Solid Edge simulation is a great tool for designers to optimize their designs in a working environment, ensuring that they're not only strong enough, but also not over-engineered and costing more than necessary in manufacturing costs. With studies to test for strength, thermal, vibration, buckling, and even fluid flows, Solid Edge simulation helps designers to know exactly how their parts and assemblies will work well before they're created. Oh, and also rest easy knowing that the results are true, as the underlying engine uses Siemens' own software such as FEMAP and Nastran, industry-leading simulation technology. Another key segment of the portfolio is manufacturing. Solid Edge continues to push the envelope, developing solutions for increasing technological advancements with manufacturing processes. Two of the main manufacturing processes prevalent today are additive and subtractive manufacturing. Additive manufacturing describes creating parts by building material on top of itself, as seen with 3D printing. Solid Edge provides users the ability to not only directly connect to a printer and fully control their print output, but also to automatically receive quotes on costing of design parts from popular 3D print businesses, where they'll print and ship them straight to your door. And next, subtractive. Subtractive manufacturing is the concept of removing material from a larger chunk, carving out your final designs with CNC turning or milling operations. Solid Edge has scalable computer-aided machining solutions, or CAM for short, designed to do just that. From direct interaction with the model for associative toolpath assignment, G-code simulations to show the full finished manufacturing process, to 2.5-axis and up machining process support, Solid Edge CAM Solutions supports digital instructions for manufacturing parts, no matter the complexity. Next up, data management. No matter the size of a company or the amount of design work done, secure and accurate data management is important to get control of your data, improve collaboration, and speed completion of your design projects. Data management is another area of the portfolio that continues to grow with advances in technology and the demands of industry. To answer these demands, Solid Edge provides scalable data management solutions to meet the specific needs of different manufacturers. These solutions are broken up based on the target audience it is designed for. We have entry-level for VSB or very small businesses, mid-level for SMBs or small to medium-sized businesses, and high-end for enterprise or very large businesses. First, our entry-level solution, built-in data management. Built-in is delivered free with every seat of Solid Edge and requires no IT overhead, as it leverages Windows indexing and file control functionality. It is primarily intended for VSB or very small businesses with 1 to 5 seats of Solid Edge, but is also a great starting point for any company, offering key data management functionality such as check-in, check-out, file locking, search and where use tools, unique document naming enforcement, and cloud-based collaboration. These tools and capabilities allow built-in users to maintain the integrity of their data on a day-to-day basis, as well as allows for a much easier process of transitioning if a larger data management solution is needed down the road. Next are mid-level and high-end solutions. The mid-level solution is intended for SMBs or small to medium businesses with 5 to 15 seats of Solid Edge that generally need more complex processes for data management. This includes defining user roles, automated development and release processes, and management of non-CAD data. Depending on a customer's needs, mid-level data management can be accommodated for in multiple ways, primarily with Teamcenter Rapid Start, but with new unique capabilities being added as new technologies and challenges arise. Teamcenter Rapid Start is a pre-configured delivery of our high-end data management solution, Siemens PLM Software's Teamcenter, the most comprehensive product lifecycle management solution available today. Teamcenter provides users fully customized control over how they wish to work with and store their data. With direct access to your parts and assembly files from within the Solid Edge application, and the automatic completion of many tedious data management processes, accessing and working with your technical data is faster and more intuitive than ever before. While the intent of the above-mentioned solutions are based on business size, each of these scalable options can be used by any size business, depending on the complexity of their design processes. And finally, Solid Edge apps. To provide additional solutions outside of those in the core portfolio, Solid Edge provides capabilities to solve a wide variety of design and manufacturing challenges. Solid Edge apps provide everything you need for a fully customized solution, from PCB and wire harness schematic creation to dynamic simulation and technical publishing capabilities. For more information and a full listing of available apps, check out the Solid Edge app marketplace online. Not only can Solid Edge capabilities be customized to fit individual customers, but the portfolio solutions seen earlier provide essential tools for specific industries that Solid Edge has a significant presence in. Our primary industries served include industrial machinery, industrial food processing equipment, agricultural machinery, medical devices, oil and gas equipment, and consumer durables. But, as with all software and technology, new industries are continuously coming into the fold and benefiting from the solutions that Solid Edge provides. In addition to the type of company or industry being served, Solid Edge is also highly sought after due to its affordability. Solid Edge's portfolio of affordable, easy-to-use tools provides ideal solutions for very small businesses, small to medium-sized businesses, and subgroups and contractors within larger, enterprise-focused companies. Solid Edge has gained recognition serving some of the world's most recognizable companies. These are just a few of the well-known names of over 43,000 engineering companies worldwide, and as they've come to know, Siemens PLM Software's Solid Edge provides valuable solutions to help solve everyday challenges with ease. Solid Edge customers maintain a level of increased productivity, enabling them to deliver sooner, lower their business risk, and grow revenue at a higher margin, leading to increased satisfaction. This is seen through reductions in design and manufacturing time, design rework efforts, and many more process improvement capabilities available with Solid Edge. So now that you've seen what Solid Edge is, let's take a moment to define the top 5 business reasons to use Solid Edge in industry. First off, Siemens. Solid Edge is a Siemens PLM software product. Siemens PLM software has a unique understanding of manufacturing, as it has been in business for 165 years and has around 300 manufacturing plants worldwide. This allows us to have a better understanding of manufacturing and industry, which is highlighted with the types of solutions offered. Secondly, Solid Edge is a part of Siemens PLM software's portfolio of innovation. This makes Solid Edge a high-technology software with strong research and development resources. In addition to this, Solid Edge customers have the ability to work with other members of the PLM portfolio, such as Teamcenter, Technomatics, RuleStream, and NX, just to name a few. In fact, most noticeable is that Solid Edge has the best mainstream CAD integration into the world-renowned Teamcenter in terms of user interface and underlying functionality with Teamcenter data management PLM processes. Third on the list is the Solid Edge portfolio of tools seen earlier, used to address all aspects of the product development process, from 3D design, simulation, manufacturing, data management, and more, thanks to a growing ecosystem of apps. The fourth business reason to use Solid Edge is synchronous technology. We covered this a few minutes ago in much greater detail, but just as a reminder, this is the unique modeling technology paradigm found only in Siemens modeling software such as Solid Edge in the mainstream industry, providing fast design and development and the ability to work with any CAD data. And finally, accessibility. Solid Edge has great licensing options like cloud-based licensing. This gives customers licensed access to Solid Edge on any computer in any location via the cloud, preserving all of their custom settings regardless of what machine they're using, as well as access to their CAD files through a cloud-based storage provider of their choice, like Dropbox or OneDrive. Also remember the other licensing available, like subscription-based licensing, where a customer can rent Solid Edge on a low-cost monthly basis, great for startup companies and those who only need access to the software at specific times in their design cycles. And of course, the more traditional perpetual options for Solid Edge ownership. So there you have it, the top 5 business reasons to choose Solid Edge. Leveraging Siemens' experience and the portfolio of innovation to provide the most complete product lifecycle management solutions. Solid Edge portfolio for intuitive tools for all of your product creation and manufacturing needs. Synchronous technology to help you design better. And the full flexibility and choice of accessibility. Solid Edge and Siemens PLM is committed to solving the engineering challenges you face every day. Thank you for your time. Solid Edge, design better.